The total distance traveled is how much? 95 kilometers. Now, what is the shortest distance? So there is only one possible path which we call it as a shortest path, and that is called as displacement. For example, the person is going from school and along this direction and reaches to the house, and if the final position and the initial position of an object are same, then we say in this case the displacement is going to be 0. Hi everyone. So today let's learn about the difference between distance and displacement. These are very fundamental definitions and let's explore. So let's consider there is a straight line. So there is a person Ram. He starts his journey from O. There is point O, and how it goes? Reaches to the point A. So he comes to this point, start from the O and reaches to the A, then return back to C. So let's just draw. So for example, he starts the journey at this point, then he moves along this straight line, reaches to A, then comes back, then he will come back to point C. There is a point C here. Okay. So now what is the total distance traveled? Total distance. So he starts here from 0 to 60. That is 60 units. Whatever the, okay, units is kilometers. 60 kilometers plus he will come back. So from 60 to here, how much is this? From 60 to 50, 10, 20, 30 and 5, that is 35. So 60 plus 35 kilometers, that is going to be 95 kilometers. Okay, the total distance traveled is how much? 95 kilometers. Now what is the shortest distance? So this is the initial point. This place is the initial point and this place here is the final point. So what is the shortest distance? It is only this much. And how much is this? This is 25 kilometers. So shortest distance between initial and final position is how much? 25 kilometers. Okay. So now there are many different ways. Let's suppose you start the journey at point A and you have to reach to point B. There are different paths. There is path number 1, path number 2, path number 3. You can choose whichever path you like. Okay, and if you go, let's say from path 1 or path 3, you cover a larger distance. But there is only one path, that is this path number 2, which is the shortest path, right? This path. So there is only one possible path which we call it as a shortest path, and that is called as displacement. So what is displacement? It is the shortest path from the initial point to the final point, that is called as displacement. So it has magnitude and direction both. So what is the magnitude? Magnitude is length of this shortest path. And what is the direction? Direction is this arrow from A to B. This arrow will give you the direction. Okay. So magnitude is the shortest distance and direction is from the initial point to the final point. For example, here, this is point A, point B and point C. Let's suppose this is a 90 degrees. So if this is 90 degrees, this is like a right angle triangle. So this person A cycle from A to B, that is from this tree to the house and from the house to another tree. This 4, this 3. There are different ways to go from A to C. There is a one path. The path length is 4 plus 3, which is 7 meters. And there is another path which is a straight line and the path length is 5 meters. There is also the shortest path. So if this is the shortest path, the displacement is going to be 5 meters. Understood now? The distance, there is a distance 7 meters or 5 meters, but the displacement is only the shortest path. Another example, for example, the person is going from school and along this direction and reaches to the house. This is going to be the total distance traveled. But what is the displacement? The shortest path is our displacement. Clear? So now again, there are different ways to go from one place to another, but only one shortest path, that we call it as a displacement. Alright, you can see here, starting at here, then reaching to 6 meters. So that is the, how much? That is the displacement. When object is moving along a straight line. So here the examples, these are not straight line. There is along the horizontal, there is vertical, horizontal. So there is not a straight line. But here, this motion is along the straight line. So whenever object moves along the straight line, the distance and displacement are going to be equal. Okay. So what are the differences between distance and displacement? Distance is the actual path length. It is a scalar quantity. We are going to learn in details about the scalars and vectors. Just I'll tell you in brief what is a scalar. Scalar is those quantities which are defined only by their magnitude. For example, time. If I say 2 hours, or if I say mass 60 kg, so these are the scalar quantities. Similarly, distance is also a scalar quantity. It cannot be negative. You cannot have, let's suppose, distance as -2 meters. You will always say 2 meters or 0 meter. Okay, it cannot be negative. But displacement is the shortest path. It is a vector quantity. That means it has magnitude as well as direction, and it can be positive, negative or 0. So we know how it can be positive, but let's just understand how it can be negative or 0. For example, you see these two cars, the red one and the grey one. Red one is moving backwards. The grey one is moving in the front. So if a car or if an object is moving along the positive of the x-axis, moving towards right or positive of the x-axis, then we say that this displacement is positive. If it is moving towards left, then this displacement is towards negative of x-axis, that is negative. This is a negative displacement. If it is moving along the y, if it is going upwards, this is positive. If it is going downwards, this is negative. So in this way, the displacement can be positive, can be negative. Going towards right, positive. Going towards left, negative. Going up, positive. Coming down, negative. And when the displacement is going to be 0, can you tell me one example? So, okay, for example, if a particle starts here, then moves some distance and return back to the original position. So now in this case, the final position and the initial position both are same. And if the final position and the initial position of an object are same, then we say in this case, the displacement is going to be 0. Clear? So the next one now. So there is a question. These are the different objects moving in the different direction. So we have to calculate their displacement. So let's just find these are their starting positions. Okay, and their final positions. So this is a final position somewhere here. There is a final position. This one, let's consider it to be here. This is a final position. Okay, so now what is a displacement? Displacement, there is a vector called as S. This symbol we use for the displacement. And what is the displacement? Displacement is nothing but final position minus initial position. Okay, let's call these objects as A. There is object B, object number C, and object number D. So let's find out their displacement. So how will you calculate? for the object A, the final position is 7. So final position 7 minus the initial position which is 0. So displacement is 7 for object A. How about object B? The final position is 7, initial position is 12. So for object B, final position is 7, initial is 12. So 7 minus 12 is minus 5. You see here, for the object B, displacement is negative. And you can clearly see the object is moving to the negative x-axis, to the left. It is moving to the left, right? The total displacement is to the left. That is the reason here the displacement has negative sign. Let's do for the object number C. So for the object number C, the final position is 10, initial position is 2. So final position 10 minus initial 2, which is 8. So this is plus. This object number C has a net displacement to the right. It is moving, like here it was going to the right, then came back, then again going to the right. But the total net displacement is to the right. That is the reason the displacement is positive. And let's solve the object number D. The final position is 5 and the initial position is 9. So final position is 5 minus initial 9, which is minus 4. So now it looks like, it appears to be, the object now is moving to the positive direction. But the net displacement, you see there is a final, there is an initial, and this is the net displacement. Net displacement is towards left or towards negative x-axis. That is the reason the displacement symbol or sign here is minus 4. Clear now? So this is how we calculate the displacement and distance of the different objects. So that's it. Thank you so much. Bye bye.